Hi, everyone, and welcome back to Organic Chemistry on YouTube. Today, we're going to be talking about organic synthesis from alkenes. So the basics of this reaction involves alkenes acting as nucleophiles. The two electrons in the pi bonds will act as nucleophiles that can attack an acid or another electrophile to create an alcohol. During this reaction, which is stepwise, which means we create a reactive intermediate where that reactive intermediate is a carbocation. So suppose you had the reaction of cis-2-butene in the presence of hydronium, H3O plus, and H2O. The product that results from this reaction would be an alcohol. We know it's an alcohol because of the OH group. Okay, so let's dig into the mechanism. Okay, so here's the mechanism. Like I said before, the two electrons in the pi bond are the nucleophiles. So I'll show those here in green. So these two electrons attack the hydronium molecule. These electrons come and attack the hydrogen, the acidic hydrogen, and then move the two electrons from the hydrogen-oxygen bonds back onto the OH2, onto the water. Now, when we think about this process happening, it means that the arrows are making a bond between one of the carbons and the hydrogen. So when it deprotonates this acidic hydrogen on hydronium, we have this hydrogen here, and what's left over is a carbocation because you've used the two electrons that are in that pi bond to create the carbon-hydrogen bond that we show in red. This is a relatively stabilized secondary carbocation, which then can then be attacked by a resulting nucleophile. And that nucleophile is water. As you can see from the arrows I show in the first step, the two electrons from the hydrogen-oxygen bond get added to the OH2, and then that as a nucleophile can attack the carbocation like this. And that results in this structure, which has a very acidic protonated alcohol there on the second carbon from the left. So another water molecule can come and deprotonate that hydrogen, kick the electrons back onto oxygen, and form the product, which is the alcohol from the original reaction scheme. Okay, so from there, you'll notice that here I've picked a symmetrical alkene. There's not a preference for adding to one carbon or another because they're both symmetrically equivalent, but there are examples where there's a preference or a regioselectivity of adding this water onto the carbocation, and that'll be covered in the next episode. In the meantime, there's some questions you might want to ask in office hour. One, how do I know if an acid is strong enough to react with an alkene? Two, are primary carbocations allowed? What if they are resonance stabilized? And three, are other products possible in other reactions? With that, thanks very much for listening. This has been Organic Chemistry in 5 minutes or less.